All right, we're going to go ahead and continue with, let's see, 1.3. So the definition of evaluate in this case is going to be to substitute a number for each variable in the expression and then simplify using order of operations. So when we're talking about order of operations, we're talking about PEMDAS. So let's go ahead and look at a couple of problems. And this is using example 2. It says, what is the value of the expression for the given variables? Okay, let's go ahead and look at A. Now the first step is to rewrite it so that it looks clear. So I have 7 open parentheses a plus 4 close parentheses plus 3b minus 8. And we know that a equals -4 and b equals 5. So then we're going to substitute -4 for a and 5 for b. So with the -4, I still want to put that in parentheses. So I use brackets and parentheses in this case. So I have 7 bracket -4 plus 4 bracket, a closed bracket plus 3 times 5 minus 8. I'm going to solve inside the parentheses or inside the brackets first. So I have -4 plus 4. I get 0. And so I can change that bracket to parentheses. So there's like a hierarchy, and I'll go over that at the end. I have 7 times 0 plus 3 times 5 minus 8. And then as I start from left to right now to simplify, I have 7 times 0 is 0. 3 times 5 is 15. And then I bring down the minus 8. And then I get 15 minus 8. And I'm going to box my final answer, which is 7. Okay, so let's go ahead and look at B. So for B, I have x over 2 plus y squared. And I know x is 1 and y equals 1/2. And so I say x over 2 plus y squared. And I'm going to substitute, so I have 1/2 plus 1/2 squared. 1/2 squared has to be inside the parentheses because you have to apply the exponent to both. So when I expand it, I get 1/2 times 1/2. And then when you multiply fractions, you multiply going across. So then I get 1 times 1 and then 2 times 2. So I get 1/4. I have 1/2 plus 1/4. I need to find the common denominator, which is 4. It's 2 times 2. So you're going to multiply the 1/2 times 2, the numerator and denominator. So 1 times 2 over 2 times 2 plus 1/4. So I get 2 over 4 plus 1/4. My answer is going to be 3/4. Now we're going to look at where it's your turn. And for A, it says, what is the value of the expression for x equals 6 and y equals -3? If you notice, we have the x squared minus y squared in parentheses. So it's 2 times x squared minus y squared divided by 3. So if I substitute, I get 6 squared minus, and then I put the -3 in parentheses, and it's squared. And then the 2's on the outside. I divide all that by 3. So what you need to know is that -3 squared is actually -3 divided by -3 times -3. So I get 2 times 36 in the parentheses minus 9 close parentheses divided by 3. I'm still dealing with only what's in the parentheses, so it's 36 minus 9. So I get 20. Yeah, so I distribute that negative. So again, I get 26 minus 9, or 36 minus 9. 2 times 36 minus 9 divided by 3. So 2 times 27 divided by 3. Order of operations says you multiply the top and then divide. So I'm going to get 54 divided by 3, and the answer is going to be 18. So for B, it says, what would the value of the expression, will the value of the expression change if parentheses are removed? And it actually does change. So let's look at what it's going to be. It's actually going to be, if we remove the parentheses, we're just going to put the 2x minus 2x squared minus y squared divided by 3. So I get 2 times 6 squared minus open parentheses -3 squared divided by 3. Again, -3 squared is -3 times -3, so I get a positive 9. So I get 2 times 36 minus 9 divided by 3. 72 minus 9 divided by 3. So then I get 63 divided by 3, and the answer is going to be 21. So it's asking what happens, like why would the value change? Explain it. So there would be no distribution, and the solution is larger. So let's go ahead and look at the definitions of coefficient, constant, and like terms. So I have this very long polynomial, or this very long expression, 3x squared plus 5x squared plus 9y to the third 6z plus 2yz to the third minus 4y to the third z plus 6. And we're going to use the expression above to define term, coefficient, and constant. So here's what you need to know. A term is an expression with a number, a variable, or a combination. So if I talk about all the terms in this polynomial or expression, all of them are terms, except for the number 6. So it's 3x squared, 5x squared, 9y to the third z, and all of them basically. So the next is going to be a coefficient. A coefficient is a numerical factor of a term. So it would be the number right in front of the variable. So it would be, we start from the first variable, it'd be 3, and then it'd be 5, 9, 2, -4. And then if we talk about the word constant, it's a term with no variable, which is basically 6. So now let's talk about like terms. Like terms basically says that the terms have the same variables raised to the same powers. So an example of that would be 3x squared and 5x squared based on the polynomial, and also 9y squared z minus 4 9y to the third, and then minus y to the third z. Let me correct that. Okay. All right, so now we're going to simplify each expression. So I have 7z squared plus 3y squared plus 2y squared minus 4x squared. So I rewrote that. And basically what I did is I used symbols to collect like terms. So underline are all the x squares, and then the y squares have boxes. So then that's what I combine. So 7y squared, or 7x squared minus 4x squared is going to be 3x squared, and then 3y squared plus 2y squared is 5y squared. And that's my solution. So let's go ahead and look at B. B is pretty unique because you have distribution. So I have a negative times 3k plus m plus 2 times k minus 4m. So the blue arrows mean that I'm going to distribute that negative into the parentheses, and then for the second set, I'm going to distribute the 2 into the parentheses. So I have negative times 3k, I get negative 3k, I have negative times m, I have negative m. So the next set is going to be 2 times k, so I get 2k, and then 2 times negative 4m is going to be negative 8m. I'm collecting like terms, negative 3k plus 2k, and then negative m minus 8m. Then from here I get negative k minus 9m. Your turn. So what we're going to do is we're going to simplify each expression. So for A, I have negative 4j squared minus 7k plus 5j plus j squared. So the only things that really go together are going to be the negative 4j squared and the j squared. So when I combine those, I'm going to have negative 3j squared. And it's because the k and the j don't go with anyone else, we're just going to rewrite them underneath. So that's your solution right there. Okay, now let's look at B. B is negative, so it's distribution, so it's negative 8a plus 3b plus 10 times 2a minus 5b. So when I distribute, again, we're distributing that negative like it's a negative 1. So it goes into the first set, and then the second set gets a distribution of 10. So I get negative 8a minus 3b plus 20a minus 50b. The negative 8a and the 20b go together, or the 20a go together. So the 3b and the negative 50b go together. It doesn't matter the signs, it just has to have the same variable and exponent. So then I get 12a minus 53b. Okay, see you in class.